Calculating cement ratios and identifying channels. This video shows how to compute cement ratios and detect channels with the automatic identification algorithm. Segmented sonic tools output maps of amplitude for a number of receivers, typically located at 2 or 3 feet from the transducer. This information can be used to detect channels. The first step entails determining the fraction of sectors that fall in different amplitude ranges. This is called cement ratios. From the Well Integrity tab, click on Ratios. The azimuthal measurements are categorized as good, acceptable, and bad cements, based on the sector's amplitude. These values are a function of the type of cement and pipe diameters. The ratios track shows the fractions versus depth, from which the analyst can quickly assess the cement coverage and quality. The sector maps clearly show high amplitude intervals that extend for hundreds of feet. These are called channels. The channeling option offers two options: an interactive definition and an automatic one. Explore the latter. First, the source of amplitude to be used is selected. For segmented sonic, typically the maximum amplitude of all sectors is selected. Then, the minimum length, perimeter percentage, and minimum amplitude for channeling identification are provided. The well integrity zones track show in blue the channeled intervals that meet the criteria defined by the analyst. These blue zones can be further modified manually. This workflow is also applicable for ultrasonic logs. Some tool vendors output the cement ratios by categorizing the acoustic impedance in various ranges. The analyst may wish to regenerate the ratios based on more information about the cement and borehole fluids. First, the appropriate acoustic impedance image is selected, in case several are available. The categories now include micro-debonded material, gas, water, and cement. These are defined by the lowest acoustic impedance value in the range. For example, a minimum cement impedance of 3.5 megarails is entered. This results in a larger liquid fraction compared to the tool output. Revert back to 3 megarails. The automatic channeling option works, as explained, for segmented sonic tools. The only difference is that the channels are now identified using a minimum acoustic impedance curve, and the threshold represents the maximum value for liquids. It may be beneficial to display the data in 3D to qualitatively identify the channels. Right-click on the acoustic impedance or segmented sonic map and select Explore. Click on Cylindrical. A particular joint or depth range of interest is displayed. Channels are easily seen by filtering out the data values whose impedance indicates liquids or gas behind casing, typically less than 3 megarails. A similar display can be used for segmented sonic tools, this time filtering out large amplitudes that would indicate channeling. This concludes this video on calculating cement ratios and identifying channels.